Hello students, in this lecture I am going to discuss about classification of instructions of 8085 microprocessor. So microprocessor instructions can be classified based on various parameters such as functionality, that is operation, or you can say operation based upon their operation. Then second is length, or you can say the size of the instruction. And the third one is operand addressing, or you can say the addressing modes. So based upon all these three terms, we can classify the instruction set of 8085 microprocessor. So moving ahead, first one according to the addressing modes. So basically there are various techniques to specify data, or you can say specify operand for instructions. There are various techniques to specify operands for instructions. For example, 8-bit or 16-bit operand may be directly given in the instruction itself, or the address of the memory location or input output port or input output device where operand resides may be given in the instruction itself, or in some instructions only one register is specified and the content of the specified register is one of the operands and it is understood that the other operand is in the accumulator. Or some instructions specify two registers and the contents of the registers are the required operands. Or in some instructions, data is implied. The most instructions of this type operate on the content of the accumulator. So as I've told you, I've told you a number of points of specifying how we can specify the operands in an instruction. Depending upon that, we have various addressing modes. So what is addressing mode? We know each instruction requires certain data, or you can say each instruction requires operand on which it has to operate, on which the instruction has to operate. The different ways that a microprocessor can access operand are referred to as addressing modes, or you can say the different ways of specifying operand in the instruction is known as addressing mode. It's known as addressing modes. So 8085 microprocessor has 5 addressing modes. So here I have listed the terms. What is addressing? Like every instruction of a program has to operate on a data. The method of specifying the data, or you can say the method of specifying the operand to be operated by the instruction is called addressing. And 8085 microprocessor has 5 different types of addressing modes. So these are the 5 different addressing modes of 8085 microprocessor, that is immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and implicit addressing mode. So what is immediate addressing mode? In an immediate addressing mode, 8 or 16-bit operand is specified as a part of the instruction itself, and the other one is a register. In 8085 microprocessor, the instructions under this category have I letter. As you can see, I have given the example of immediate addressing mode, that is MVIB3H or MVI820H or LXI-D10FFH. So these instructions have letter I. So all those instructions which have letter I, like MVI, LXI, so these instructions fall under immediate addressing mode category. And the 8-bit or 16-bit operand, this is 8-bit operand or 16-bit operand, is directly given in the instruction. For example, MVIA 20H, what is the function of this instruction? It moves 8-bit, this 8-bit 20H, 8-bit immediate data into the accumulator. Similarly, what is the function of LXI D10FFH? It moves 16-bit immediate data, that is 10FF, into the DE register pair of 8085 microprocessor. The next addressing mode, so this is the format of immediate addressing mode. We have the opcode and the operand both written in the instruction. So here the opcode MVIA data and the operand is directly given in the instruction. The next addressing mode is register addressing mode. The register addressing mode specifies the source operand, destination operand, or both to be contained in an 8085 registers, that is 8085 general purpose registers. This results in faster execution since it is not necessary to access memory locations for operands. So if you want to perform a program, fastly, or if you want faster execution, then register addressing mode is considered to be the best mode for faster execution of the program, as the microprocessor do not have to go to the memory or do not have to access the memory for the operand. The operand is stored in the microprocessor for this type of addressing mode. Now, for example, MOVAB, as I've told you, in this instruction, what happens? Both the A, that is both the operands, are the general purpose. This source and the destination operand both are general purpose registers. So this is the format for register addressing mode. Here I have shown this is the instruction. For example, MOV A, B, this is opcode and operand. Opcode and general purpose register. So opcode and the register, whenever I'm saying that the register is an operand, means the content of the register is an operand. So what happens, how this instruction gets stored in the what happens in this instruction? This is opcode and we have the operand. And what is the operand? Operand is the content of the register. And where this register is located? This register is located inside the microprocessor, like register B, C, D, E, H, L, etc. Now the next addressing mode is direct addressing mode. So in direct addressing mode, the 16-bit address of the operand is given in the instruction itself. So as I've shown an example like LDA 1050H or STA 2400H. So this 16-bit address of the operand is specified in the instruction. So for example, STA 2400H, what is the function of this instruction? It stores the content of the accumulator in memory location 2400H. So here the memory location is 2400H and the operand is going to get stored in the memory location from accumulator. Or you can say LDA 1050H, what is the function of this instruction? It loads the 8-bit content of memory location. So this is the memory location address. It stores the content of the memory location into the accumulator. So this is the format for direct addressing mode. What is how the format is written? We have the opcode, and the memory address, opcode and the memory address. So any instruction written in this format will come under direct addressing mode. And what is the operand here? Operand is the content of the memory location. So this is the memory. This is the memory location where the operand is placed. Operand is located. So opcode and the memory address, and the content or the operand is the content of the memory location. So I am ending this lecture here. We will continue with the addressing modes in the next lecture also.